Thank you, Nicola. Thank you, everyone. I apologize that my voice is slightly strained, but I'll try to go through this. As Nicola said, I'm a researcher at the University of Washington. I'm also a senior data science fellow at the University of Washington eScience Institute, which is our data science institute, where I also run the summer school in our academy that uses 2I2C tools and Jupyter in order to teach neuroscientists about data science. For a while, I was an editor at the Journal of Open Source Software, and I want to tell you a little bit about the journal because I think it relates very closely to a variety of topics that we're discussed today. I was not quite there from the very start. The journal was started in 2016. I joined the editorial board in 2017, beginning of 2017, and I was an editor until the end of 2021. I should give credit to Arfin Smith. Many of the ideas on the slides that I will present today are taken from a slide presentation that Arfin created. And Arfin is also the person who created JOS and is still the editor-in-chief of the journal. Oh. This. Okay, so the Journal of Open Source Software is a developer-friendly open access journal for research software packages. It's committed to publishing quality research software with zero article processing charges or subscription fees. First of all, why do we need JOS? Well, software is everywhere. I don't need to tell the audience in this room. Software is important, as you probably all know. It's very succinctly described in this sentence from a paper from a few years ago. Software turns a theoretical model into quantitative predictions. Software controls an experiment, and software extracts from raw data evidence supporting or rejecting a theory. And so software has become central to science. But software by itself is not a creditable research activity. Writing software in the lab, just the act of writing software is not the thing that you would get credit for. So JOS was created on the premise that we can embrace the hack. The main purpose of a JOS paper is to make the work that was already done on the software publishable and citable. So paper preparation itself and submission for software that is already properly engineered should take no more than an hour. The writing of the paper itself is a side effect of the work that has already been done. And so papers are usually rather short, under 5 pages, and they include mostly a summary describing the high-level functionality of the software for a diverse non-specialist audience, their statement of the need that illustrates the research purpose of the software. And I should emphasize, JOS is meant primarily for research software, software that is used in other research and therefore will be cited by other researchers, reference to related work, and acknowledgement of any financial support. And importantly, a JOS paper should not include any novel results. Those results should be published separately, but the JOS paper, the focus of the JOS paper is the software. The goal of the JOS journal is to be as conventional as possible when it comes to integrating with the scholarly ecosystem. So we use a variety of standard tools, ORCID for login, metadata and issue metadata and DOIs are deposited to Crossref. Papers and the reviews are archived with Partico, and software is archived with Dryad, Figshare, Zenodo, one of these standard DOI providers. And then the papers are also indexed by standard indexing mechanisms, Google Scholar, Scopus, PubMed, etc. So they become standard objects of the literature. Another goal is to follow best practices where they exist. So the papers are open access and licensed under CC BY, where authors retain the copyright to the work. The review process enforces the open source definition that was defined by the Open Source Initiative. So the software has to be released under an open source license that is recognized by the Open Source Initiative as an open source license. The journal has clear and transparent ethics, open ownership, business model, and governance statements. So you can find all of those on the Journal of Open Source Software's website. So it's clear who makes decisions, how decisions are made, and what the overall business model of the journal is. And then, importantly, this is a journal, and so rigorous and transparent peer review process is part of the process. The goal is really to provide a valuable service to authors. minimize author effort beyond existing software documentation they already have written. And adequate documentation is a requirement for paper acceptance. So as part of the review process, the reviewers will go and check that the software has documentation in addition to reviewing the software itself. And so reviewers go, look at the software, review the documentation, review the functionality, make sure that it has tests, make sure that it has all the components of good, well-engineered software. The review hinges around transparent, achievable review criteria. In fact, there's a checklist, and reviewers go through that checklist, check one by one these criteria, and check them off as part of the review process. It focuses on improving submissions and not rejecting them, although there are criteria for quality, and papers do get rejected. Article processing charges are 0, and all the papers are provided as open access. Another goal of the journal is to leverage open source workflows where possible, and so reviews are carried out fully on the GitHub website using the standard mechanisms that we use in open source software in order to review software. Paper typesetting layout uses Pandoc, another open source tool for typesetting layout. And editorial procedures are automated using a bot called Editorial Bot. This is also an open source software project that helps manage the labor-intensive editorial tasks like minting DOIs, producing previews of the paper, and so on. So this is the workflow roughly. The authors, oops. How do I go back here? Okay, go back. And I'll just wave my hands at this. The authors make the software available in a repository with an open source approved license, writes a short paper, and then submits to JOS by filling out a short form. Once that's submitted, an issue is created on a GitHub repo where the reviews are managed. An associate editor and chief reviews this for size and scope and may reject the paper just on the merits of the size and scope. And if not, then assigns a reviewer and editor, which then assigns 2 reviewers who review the submission. During that time, the paper is under review, and the reviewers will raise comments, post issues on the GitHub repository of software, or on the discussion that is the main review issue for this paper. The authors go and fix the issues, and then eventually the editor accepts the paper, and the authors archive the software. Once that happens, the paper is published, and then it receives a DOI. So the paper itself has a DOI as well, and that completes the full cycle. No, the other way. Okay, so how well has this been going? Like I said, the journal has existed since 2016. During that time, it's published over 2,500 papers, over 2,000 reviewers have participated in this process. The editorial board has had more than 100 editors on a variety of, and a really wide range of scientific topics. One of the challenges here is that you need to cover both the scientific topics that are used in the software and also know something about software. In July 2020, the journal decided to add a criterion of substantial scholarly effort to the review criteria, and rejection rate since then has been around 15 to 30%, depending on the month, in the pre-review process, an additional 5% in review. So the journal does reject some papers based on kind of scale, scope of the software that is being submitted. How is it working for authors? Well, more than 200 papers have been cited larger than 20 times. And there's one paper, Welcome to the Tidyverse by Wickham et al. From 2019, that's been cited more than 14,000 times. There are several other papers that have been cited kind of like in the thousands of citations scale. So that's, I think, successful in just meeting the hack, the need for the hack that was described in my slides. Finally, one of the interesting aspects of JOS is its low operating costs. And there's a blog post there that I link, and I hope to make the slides available so you can go and take a look at that describes the cost model in more detail. Publishing a paper in JOS costs approximately $4.75. There's annual Crosswork membership, annual Portico membership, there's minting the DOIs itself, and then there's website hosting. But that's the full extent of the cost of JOS. And assuming a publication rate of about 200 papers per year, that comes out to be just under $5 US per paper. which is very, very cheap. And that cost has been carried mostly through grants that have funded JOS, the operation of JOS. All the work that is being done, though, by editors, by authors, by reviewers, is of course volunteer work, and that makes some complications. I'll talk about challenges in the next slide. I just wanted to mention, similar to the ideas behind 282C's spread, the idea here is also that open infrastructure generalizes. So now there's a family of open journals, Journal of Open Source Software, the Journal of Open Source Education, which follows a similar kind of model for open educational resources. And the infrastructure has been used by a couple of other journals as well. And there's my understanding that NeuroLibre has also taken that and evolved it into its own infrastructure. Not mentioned on this page, maybe we should fix that. Some of the challenges for this, the main challenge I'd say is scaling in the human dimension. Finding editors, finding reviewers, and keeping everyone engaged and on time to do the work that needs to be done. Reviewing software is labor intensive, requires work, it requires downloading the software, installing it, running it. It's a lot of work, and everyone makes that effort. Review effort is significant and very hard to sustain as volunteer effort. However, because we all work in a platform that we're familiar with, that does ease some of the procedure. That does also pose a challenge because the use of GitHub as a platform only works because everyone involved knows how to use GitHub. So might not generalize to other domains in which GitHub is not used as often. So to conclude, JOS addresses some of the challenges of incentives for development of useful software for science, uses conventional scholarly infrastructure, best practices, and open source tools, and that allows it to provide valuable service to authors at a very low cost. Challenges relate mostly, as always, to the human element. Generalizing this model would be challenging because of the reliance on software-specific workflows and because of the high effort that it takes to do the work that goes into reviewing, writing, managing, editing, so on. Okay, and with that, I'll conclude my presentation. Thank you for your time in this.